Hi all, welcome back to today's session, and today we are going to understand uint32. Okay. Have you ever wondered what uint32 really means in C programming and why embedded engineers use it everywhere? I find it very fascinating, uint32, and I will tell you exactly why it is important and how it is important for an embedded firmware engineer to use it in their every programming, not every programming, everywhere in the programming system, in the programming of a embedded engineer. Okay. Uh, so the first and the foremost thing, it is unsigned integer, which is exactly 32 bits wide, and the range starts from 0 to 4294967295, which means that it is a non-negative whole number. It's a non-negative whole number. Okay, and how do we calculate this ranges? It's very simple. 2 raised to 32. I know you all know, but I'm just going to write it over here. 2 raised to 32 minus 1. This is how we calculate. And it is this uint32, or or you can say uint 8, uint 16, uint 64. This is all introduced in C99, and it is included in the header file hash include std int .h. So whenever we want to use this uint unsigned integer of 8-bit or 16-bit, 32 bits or 64 bits, we have to write this header file before we start to write the code. So that is hash include in open bracket std int .h and the close bracket, right? Okay. 32-bit is a very sweet potato. It is a very 32-bit is a sweet spot in most embedded systems. Why? Because it matches the natural word size. So you know what is a word size, right? That is 4 bytes. So it matches the natural word size of any CPUs. Okay, and because of this, it makes it very easy for the engineers to, or the CPUs to, make arithmetic calculations fast and efficient. So this is one of the advantages of using uint32T. In this session, I'm going to talk about uint32 only, but it is mostly applicable, whatever I'm saying, it is mostly applicable to 8-bit, 16-bit and 64-bit as well. So the second advantage, which I can say, the plus I would say advantage, which is like many hardware registers or communication protocols and other data formats and all those, they require this exactly 32 bits wide data type. So hence the 32-bit uint32 is widely used than 8 or 16. 16 is also used widely based on whatever the registers we are using for our coding purpose. We will have to cross verify with the data sheet, and then we have to understand if it is 16-bit register, 32-bit register or 8-bit register. Based on that, we have to make the changes and use that particular register. Okay. Now coming to the next part, which is also a very important part over here, it is why it is fixed width range. Okay, a fixed width integer is what? It is a data type whose number of bits are guaranteed and never changes. So be it 32-bit, so it is going to be 32 bits. If it is 16 uint 16, it is going to be of 16 bits. So that is not going to change. It is going to be fixed. Okay, and why do we need fixed width? Because the normal C types, what we have till now used is like int, long or short. They don't have a guaranteed size. Why I'm saying this, they don't have a guaranteed size, let me write it down over here, but before that let me clear out the screen a bit. So let me explain you why the normal C types, that is int, long, short, don't have a guaranteed size. They can change depending upon the architecture. Okay, so how does it change? Let's understand it. So let's say this is an 8-bit microcontroller, this is 16-bit, this is 32-bit microcontroller, this is 64-bit PC. Okay, so let's consider this table. So first of all, we will consider the normal C integer type data type, and for the 8-bit microcontroller it is 16 bits, for 16 bits it's 16 bits, for 32 bits it's 32 bits, and for 64 PC it is 32 bits. Okay, and coming to the long, it is 32 bits for 8 bits, it is 32 bits for 8 bits, it is 32 bits for 8 bits, and it is 64 bits for 8 bits. So this creates portability bugs. So what does this do? This creates portability bugs. Hence, in embedded system, we use uint32 or uint8, 16 or 64 depending upon the register size. Okay. So here you can see, let's try to understand fixed width integer types such as uint16, uint8, uint32 and uint64, which are fundamental in embedded systems and firmware development. Because of the following technical advantages. I have chalked down the technical advantages, and it is very important point for interview as well. This has been asked in interviews. It is one of the favorite interviewers question to ask it to a embedded firmware engineer. Maybe it is a fresher. Usually it is asked for the freshers and intermediate embedded engineers. Okay, so the first one comes is the deterministic memory usage. So what happens here? What does it say? So let's consider uint16, which guarantees a strict of 2 bytes, okay, and which is essentially for efficient resource management on memory constraint embedded platforms. So this is a wherever the resources like it's a very tight memory thing where we require only, there is only space for 16-bit data, sorry, wherever there is a resource constraint of 16-bit, then we have to use it of uint16. Right. Then second comes the consistent bit width across platform. What does this mean? This means that fixed bit types provide uniform bit widths regardless of compiler or hardware, which will ensure that the predictable behavior is there. There is a predictable behavior when interfacing with any other devices. Let's say there are 2 devices to be interfaced, and for that this is a required and a must one. Okay. Third comes the accurate hardware mapping. So what does this accurate hardware mapping means or interfacing means? It means that many peripherals operate with fixed size registers, okay, such as 16-bit ADC is there, and we have to interface it with some sensor, and it needs to be of 16-bit of width. So for the correctness of representation, and and there shouldn't be any overflow or underflow of the data, whatever is been the interfacing is happening between 2 different hardwares. So that is why we require, this is being used for accurate hardware mapping or interfacing. Fourth comes the optimized execution performance. What happens here? It reduces the implicit conversion and aligns with microcontroller architecture for faster execution. So what does it mean? It means that matching variable weights to the target architecture. So whatever is the core microcontroller we are using, it has to match it with that microcontroller. So to match that and to minimize unnecessary type conversion, we use this fixed width data types here. Okay, so hence uint16 or uint32 depending upon whatever the register. Now fifth point comes is the clear and portable code. So this helps in improvising the code readability and portability. Explicitly, explicitly specifying that width and signedness is essential here in code. That will tell us like, clarity. It will give us like it is a non-negative number, it is a positive number, it is a negative number. Negative number also is being used in embedded system for temperature sensor. Let's say it's for a temperature sensor as well. So that's why it gives us very good understanding or clarity of what type of sign is, if it is a signedness, and about the width. Okay, coming to the sixth point, that is standard compliant typing. So we define that it is defined in std_in.h, which ensures uniformity and reduces the integration bugs. So these types are defined in, I mentioned it right, it is defined in this header file std_int.h, which enforces a consistent and there is a standard compliant which will help the variables declaration to be, it's very approachable. So the variable declaration is very easy to understand. Also it reduces, cross-platform integration issues as well. So usually we have the sixth point that is I'm going to discuss is the reliable protocol handling. This aligns the fixed fields in communication protocols for correct data phrasing. So correct data has been transferred from, let's say SPI is communicating with I2C or some other protocol, or sensor is communicating with I2C, whatever it is. So data sent from the sensor and the data collected at the peripheral, it should match. So for that, and it should align. Hence, we need the fixed width data types. So it is very important for an embedded engineer to understand what is uint32 or uint. So let us consider one example here, practical example. So you can see a screenshot or a code snippet on the screen. So we have included the stdio, that is input output. We have included the stdint, which for what? To include our uint32 data type. Then we have limits.h for max and all those things. Okay, mean and max of data type to be considered. Now here I have written int main in the bracket void, and in the curly braces or the main body data is uint32t x. X is a variable which is of unsigned integer. It is of unsigned integer and of 32-bit width. Okay, and it is equal to uint32-bit max. And whenever you print this value, you will get this value. Okay, I think you all know about this. I'm not going to talk about this. So the value I have written here, it is 4294967295. Okay, so what happens when I add max 1 to this maximum number, to the maximum number or maximum value? It's an unsigned integer, and unsigned integer unsigned integer in C follows modular arithmetic. What do you mean by modular arithmetic? It means like in circular form, like, or you can say, let's consider this is a clock. So if the range is starting from 0, it will go till here and it will end it here till what? What is the range? This value, 4 2 something, right? That it will be till there. So it is it follows a modular value, and this tells us that it wraps around when they exceed the maximum value. So whenever I add 1, what will happen? It will wrap around. So max plus this, max plus 1 is equal to what? 0. So we again go to the starting point over here. So the output of this code snippet is 0. I hope you are understanding. It's like a clock going. Here it is a clock. Let's say this is 12, this is 1, this is 2, and so on till 11. So whenever I strike 11 and I say plus 1, it is going to be 12. If I say plus 1, max 12 is what? It is our max number. If I say plus 1 to the 12, it will come to 1. It will not be 13. It will go to the first part of the clock. Okay. So that's how it is, like adding 1 hour to the clock. It doesn't become 13, it becomes 1. So similarly here, whenever I add 1 to the max number, it will again go to the starting range of that is 0. So the output of this code is 0. So this is one of the favorite. Let's take another example. You can see another code snippet on the screen. So we have now, this time we have considered a micro over here. Hash defines 0, Z, E, R, O is in capital, and 0, U. That is, U means unsigned number. Okay. So in the main function, we have written U in 32x, variable x we have taken, which is assigned to 0, that is 0, U in short, whenever the pre-processing happens. And what is the arithmetic operation we are doing here? It is x equal to x minus 1. So what does this expression tells us? What will happen with this expression? Any guesses? I'll give you 1 second to think about it. Okay. So what is happening here? We are trying to 0 minus 1. Do 0 minus 1. But U in 32 cannot store negative numbers. So here you are getting minus 1. So negative number U in, it's an unsigned integer. So it cannot store negative numbers or integers. Okay. So unsigned arithmetic in C uses a modular wraparound. Again the same situation which we had seen. Why do we do it wrap, or why does it wrap? So like, let's say, think like an unsigned integer, like the number of a circular clock. Okay. And if we go below 0, this is a 0. And if we go below, you wrap around to the maximum number. So what is the maximum number we have seen? 4294. Here you can see 4294, 967, 95. So it wraps around, it moves backward, and it wraps around to this maximum number. So that's the outcome of this number. Okay. Remember that if a negative value is converted to unsigned, C adds a multiple of 2 raised to n until the number fits. So what does this mean? Let's say we have number m minus 1, 2 raised to 32 minus 1, which is equal to 4294, that number. But internally what happens? Here x becomes the max number. Okay. And when we add 1 to this, it wraps around and goes to 0. So let us consider one more last final example on this topic. So here you can see we have defined the micro neg1, which is minus 1. Okay. What happens in the conversion? If a negative value is converted to an unsigned integer, C adds multiple of let me write it down. C adds multiple of 2 raised to n until the number fits in. So what does this mean is, like, minus 1 represents 2 raised to 32 minus 1, which is equal to the max value. Okay. So the max value is what? 429496729.5. Okay. So internally what is happening? It is converted to the max value when we do minus 1. Now the expression here, what we are seeing is, it is saying plus a plus b. So what is this? Neg 1 plus 1 u. So neg 1 is minus 1 plus 1. So what is happening, guys? Can you guess? Any guesses? So minus 1 is what? It is a max value, right? We have seen that it is a max value. Let me take another pen. Minus 1 represents here is a max value, and plus 1, which is equal to 0. Again it is wrapping around. Remember, guys, this is 0, this is the max value, and this is 0. So whenever I am doing again plus to the max 1, it is going to be 0. So why do we wrap around? Why the confusion happens? Many think the printed value is max. Why? Because they focus on the conversion step. All these they focus on this conversion step. But remember, every time remember, whenever there is this plus sign happening, so remember there is a another step to that, that is wrapping around. So it is in a circular form or modular form. Please remember guys, this is very important concept. These questions are asked in multiple choice questions in the interview. The interviewer might even ask this: what happens when you add -1 to +1 of an unsigned integer? Then you have going to make another 2 videos on this. I have different interview questions. I'm going to make 2 different very important questions every embedded firmware engineer gets asked on this. These are favorite interviewers questions. So please don't forget to subscribe, hit the bell icon to get the notification of my next videos, and definitely please share it with your friends or the one who needs in to understand the concepts. And whoever is going through any interview, let them, you can just support them with this video, sharing this video with them. Okay, let me know in the comment section if you like this video and you need any other explanations or anything. Okay, thank you so much.